clap your hands. Ah. But clapping your hand is not enough. About our events. Clap your hand. Yeah. So thank you a lot to join the afternoon events. How many of you actually joined in day 2 event only? Please raise up your hand. No worry, we actually cut a 1-minute video to summarize what have happened in day 1 and day 2. We are going to present this video to you so that you can enjoy this event together.
Thanks for the lovely intro. Thanks for having me here today. Thanks to the HK HouseCon people for accepting my proposal, inviting me here to speak. Like you said, my name's Dietrich. I've been working at Mozilla for more than 12 years now. So I've been working on a large open source project for a very extended period of time, doing a lot of different things. Worked on Firefox for a long time, worked on add-ons, Firefox OS. I've been an engineering manager, an engineer, a project manager. When you work somewhere for over a decade, you gotta switch things up every now and then to keep it interesting. But one of the reasons why I stay at Mozilla is because Mozilla is a nonprofit organization. It's like an NGO, but for the web, for the internet. And that mission is very, very important to me, and one of the reasons why it's so much fun to be able to come and talk to a group like you, people that believe in open source and practice open source, and talk and implement things in open ways. It's excellent. One of the parts of Mozilla's mission that, for me, keeps it endlessly fascinating and interesting is the dedication to the idea of open being innovative, that openness unlocks innovation, that things like decentralization enable more people access to do innovative things. And we're entering a period in technology where things are changing a little bit. Right now, we have our smartphones, we have our laptops, we have very visible technologies, but we're moving into a period of time where technology is going to be less visible. More and more is happening in the cloud. More and more is happening in algorithms, in data models that we don't have access to. Our own data is being shifted to these places. We have access to the means of making these things ourselves, but a lot of the technologies we're going to be interacting with over the next few years as technology moves to room-scale computing. Not just cloud scale, but where the physical spaces, like this room that we're existing in, are computers that we're interacting with. The nature of our relationship to these technologies starts to change in a few different ways. Right now, this is an example of our app lives. This is actually an Android launcher called Lens. It's experimental. It's a mess. It's terrible. But it's fascinating looking. And if anything, it gives us an honest view of how many apps we have. How many of these do we actually use? Which one of these do we actually use every day? I think the last figure I read was most people use about 7 apps per day. If one of those is your browser, you actually use a lot more websites and things like that as well. But 7 is a pretty small number. These apps are fighting for our time, fighting for our attention. But at least they're visible. We know they're there. They have a tangible sensorial experience with our eyes. We touch them, we look at them. But now, look at this. If we're buying the Alexa, room scale computing right now looks a lot like this for a lot of people. You buy one device, you can interact with it in one place. I guess you could buy a few for your house, but things might get confusing and it would be expensive. But they're advertising. This is straight from the Alexa page on Amazon. Says a lot about choice. Says a lot about the nature of how we're going to interact with these devices, because there's very few choices there. If I want to order pizza, I can only order pizza from the Amazon approved places. So it's a different type of app store. But I love how their visual really tells a story about what software we have access to through that single Amazon approved gateway to services. Now, you can implement your own services, but it's still running through Amazon. It's not direct access through a web browser. So where does this leave browsers? Where does this leave the web? What's the nature of browsers in the web when all of our services in room-scale computing and physical computing are going through a single provider? We're entering a period where computing is becoming invisible. They have the option for a device like this to make it visible. Like they try to make it look like something we'd be okay with having on our counter. But it's not really necessary, right? It could be a hidden microphone in the room. There's some visual feedback. The little ring on top makes some bleepy, colors and things like that. But really, from an interaction design standpoint, if I have to look at this every time I interact with it, it's not really serving its purpose. If I have to double check that it actually did what I asked it to do, then it's not really the ideal design. And I think things are going to be less visible moving forward. Right now, as of a couple days ago, we have 3 choices of room scale computing. Moving on up, we got choice now, people. All of those choices, though, take away our agency. They don't give us the choice of how we want to deploy our software, how we want to build our services, whether we need to ask permission for any of these services. Do we even know what the privacy and security profiles of these types of devices look like? Well, we might have a really popular service that we build for one of these devices, but do we have access to the telemetry, to the metrics, to the analytics of our users through one of these devices? Not really the same way that we do with a web page. And this is something that is really yet to figure out because these are not commodified. There are about 3 choices. You can build your own room scale computing device. You can take a Raspberry Pi very easily. You can even flash a pre-made build and get an Amazon Alexa on Raspberry Pi in your home, which means you have an open source-ish kind of hardware software solution to a problem that you may or may not have, but you're still entirely dependent on that host platform of Amazon to be able to access these services. You still can't implement a service directly. You still have to ask permission to be able to access a given service. Jasper, I thought was interesting. It's an entirely open source version of this type of conversational room scale computing, which is pretty cool. It uses open source libraries like Sphinx for speech recognition and things like that. Very interesting. I haven't really played around with it a lot yet to see what the quality is like. One of the problems with speech recognition right now is that a lot of the value in the high quality level we get from Siri or Alexa or something like that, Google Home, is due to the fact that the corpus of data that these companies are using is in-house and not available to us. So we can create open source rudimentary speech recognition solutions, but the high quality and low latency speech recognition solutions aren't really available to us yet. So I'm interested in working with Jasper and seeing what type of quality you can get out of it. But the problem remains, we're moving forward into a radically different paradigm of computing, where the room might be the computer, and the computer might be visible, and our interface with it might not be visible also. How do you get people into there? How do people know what's available? How do people know what they can do when the computer is invisible? There's some rudimentary ways we've been working with physical computing over the years to get people into these computing situations. Right now, entirely dependent on phones. But one of the things that figures like this show us, this is showing us that people use apps far more time per day, more hours per day spent in apps. But far more unique visits happen on mobile web pages by smartphone users. Now, a lot of times you see this figure used to tell a story around how more people are using apps than web. But I think the story it's telling us is a little bit different. It's telling us a story about how we use the mobile web and how the use cases for the mobile web are very different than the use cases for the desktop web. Mobile web, a lot of times, like the reason why we have 100 apps but only use 7, the use cases are small. They're transitory. We pop out of an app into a web view to accomplish a task and then move on. So we have, as this figure shows, many more unique visits to mobile web pages than we have number of apps that we use per day, but the time spent is different. So the way that we're using the web has changed as a result of us having access to the web all the time wherever we are. And I think this is going to be very true of room scale computing, where you walk into a room and you need to accomplish a task, whether it's buy something from the vending machine or change the lights or buy a ticket for a movie or any of these things, but you don't need to have those things available all the time. So how do we get people into these situations? There's a lot of ways right now of how you can walk into a room and be onboarded into a digital situation. You walk into a physical space. How do we get people from that physical space into a digital experience? This is probably the oldest and the most recognizable. A QR code is basically a bridge to a digital experience. You scan the QR code, that is usually available in a physical place, someplace you walked up to, and you are then able to access digital services through this QR code. Maybe you like it, maybe you hate it. In some places, it's super popular. Everywhere that I went in Taipei, I can scan QR codes to get discounts, to buy things through Line. I spent a week in Shenzhen. It was nothing but WeChat and QR codes all week long. If I had analytics of how many QR codes I scanned that week, it would be amazing. Probably more than I would do in the United States or Europe in a year or two. QR codes everywhere. Hong Kong's no exception. There's definitely some QR codes here. Silicon Valley is starting to write about QR codes as physical experiences because a lot of purchases are being made through QR codes in some geographies, like China. So now Snapchat has Snap codes. Facebook has Facebook Messenger codes. Of course, they couldn't use the regular QR code format. They had to come up with their own format. But it's interesting that these are now being talked about as possibly viable ways of interacting with people, even in US and EU. And this specific article was written with some really strong Silicon Valley blinders on. At the very bottom, they do mention, oh yeah, in Asia, people use QR codes too. Like, that's all you have to say? It was amazing. If Plus Tech Art is a Taiwanese company. They're based in Taipei. They build large-scale projection mapping experiences, kind of like TeamLab does. But they were being asked by their clients to build apps per exhibit, and they had a problem. Nobody was installing the app. So these companies would spend insane amounts of money to build these beautiful experiences and have an app that went along with it, but no one would install the app. So instead, they started using QR codes to open a web page that was written in Canvas, and they had the digital part of the experience. And that they went from almost zero user engagement to almost 100% user engagement, switching from install my app to scan this QR code, flipped user engagement almost entirely, where almost everyone walking into the room was willing to scan a QR code and open a URL to have this experience. The barrier to entry, even though this looks awkward and strange, is really, really low. Even though if you look at WeChat, if you look at Line, if you look at a lot of the malware and adware-ridden QR code scanners in the Play Store, the software isn't good. Even in WeChat, you have to go through this bizarre user experience flow where you have to click the add a contact. Is Line or WeChat? I think it's Line. Where you have to add a contact to get to the QR code reader. It's not even a first-class citizen of the primary UI of the applications. It's hidden away. But still, the level of user engagement was really, really high. You're probably familiar with this. I apologize for this photo. This was really dirty. This was at the grocery store, and it was kind of amazing as somebody from America being able to come here and pay with my bus and train card for my groceries was kind of wild to begin with. But this is NFC. So NFC is another way of bridging people from a physical experience into a digital experience. I'm able to pay for things. I can load URLs. I can do all sorts of things all over the place. But the ergonomics are a little different, right? A QR code, you're holding your phone up. These you have to tap, and you have to tap just right. This example was great because you can set your card down, and they have a lip there, which gets in the way of your fingers. So if you set your card down, it actually kind of gets stuck there. So you're watching everybody in the grocery store all doing this, trying to get their card back up off the scanner. So there's some ergonomics issues. A lot of places, you'll notice that NFC tap happens on a surface 45-degree angle because you can do it while you're walking on the train. Some of the stations here in Hong Kong have them flat. And you can see this thing where people do this weird body contortion as they're trying to tap the card. And here with the MTR, you also have this combination dance where you have to tap the card and spin the turnstile really quick. So you see the people that are really good at this, that are like, right? And then you can see the people that are tourists, like me, who are like, and I have bruises on my legs from the MTR. But here's another one, is if you're staying in a hotel or apartment, this is an apartment building that I'm renting here in Hong Kong, where it's NFC, but look, they had to put a sign saying exactly where you're supposed to put your card. They made this big black area that looks like it's the hit spot for it, but it's not, because the card has a hit spot this big, and the big black area only has a tiny one where that little sign is. But the hit spot actually isn't even where the little note is. It's above it, because of course, if you covered up with your card, you wouldn't know. So the sign that says where it is actually intentionally wrong. The design and ergonomics of physical computing we have not worked these kinks out yet. We've got some work to do, people. This one I saw when I was leaving Singapore, where you can shake to get a discount on cognac if you have WeChat open. I'm like, all right, I'll shake to get a cognac discount, special gift, sure. But I love how they have visual affordances for turning on Bluetooth. They have to tell you that you're supposed to shake it, but it's not really clear. So in Hong Kong, they leveled that up a bit. This is in the MTR. This is a Wonder Woman advertisement where they've got NFC, Bluetooth, QR code. They tell you that you have to turn Bluetooth on. That's pretty clear. They actually show you how you're supposed to do it if you decide to shake. There's 4 different ways to physically interact with this advertisement. It's amazing. And they took a little artistic license with the QR code, which I thought was pretty cool. The NFC chip, however, look, you can see it through the thing. They did not care. They're like, all right, we don't even know what to do. You're going to see the chip. That's cool. This one I thought was fantastic because this is so meta. It's an advertisement for this type of advertisement that doesn't have anything except a little Facebook thing in the corner. Well, that's it. There's no QR code on there. There's no NFC. The Bluetooth doesn't work. It's an ad for the stuff that doesn't have the stuff. You have to go to Facebook and manually type that in. Mind-blowing. This was probably my favorite from an aesthetic standpoint, though, because it's really beautiful. If you walk around Old Town Central, you see these all over the place. And at first glance, you're just like, wow, that's a really cool poster. It looks really nice. And then you actually read it, and you're like, hey, it says scan this. This is actually a QR code. It actually works. You can scan this, and it loads up the Old Town Central page. So I thought, like, this is a great example of how, well, maybe it's not a great example, because it looks cool, but almost everyone I've talked to has said, I've seen those. I didn't know that was a QR code. So you can't make them look too good either. So those are ways of active onboarding. There's also passive onboarding, ways where you don't want the user to interact. Bluetooth beacons is a way of doing this, where you can walk into a room and just get a notification. You don't have to do anything. If you have Bluetooth on, anyway. There are challenges here as well. But the idea with beacons is they can send a signal within a certain radius, usually like 10, 15 feet, though if there's no walls, it'll actually go a lot farther. You can actually turn the signal down to within a few meters, which is really nice. You can get a notification. People can choose to interact with it or not. You can walk into a space and actually have the space tell you what is there. Going back to that install app versus open URL commitment, really low barrier. Most people have no problem clicking on a notification. We took 100 beacons and put them all over a 9-story art school in London for Mozilla Festival, and people could walk around the building and just get notifications about what was there. So it was a way there where not only was the building telling them what was nearby, what was available, they also ended up with a record in their notifications or browser history, or if they had a beacon app, of the things that they saw, because they wouldn't have notifications from the areas they didn't go to. It also kind of gamified things a bit too, because people then started discovering areas of the building that they wouldn't have otherwise gone to. People were like, I went to the journalism floor because I wanted to collect all the beacons. So you get this weird flip side gaming interaction as well. We talked a little bit about speech recognition, but for a lot of these devices or these types of interactions, you actually don't need sophisticated speech recognition. Somebody's there. Somebody's not there. I'm awake. I'm here talking to you. You're being very quiet. That's nice. But if you're asleep, or if you're home, if you're at work, when people come and go, noise, just the ambient decibel level, can tell a story about the presence or absence of somebody. Even if you're not using speech recognition, you can use noise recognition to know if somebody came into the room. What if you had a digital display, like digital signage, that was powered off and just turned on when somebody walked in the room, saving power, saving electricity, or had an interaction when someone walked in the room? This was an experiment that we did at an IoT hackathon in Berlin around presence, absence, and privacy. What do you know if a camera is in the room? Like right now, we're talking about the 3 devices I showed from Apple, Facebook, and Amazon. Those use microphones. You're like, is somebody listening? That's the fear, the canonical fear. But a lot of times, these devices are going to have cameras too. Computer vision is getting better and better. We're seeing that in the AR stuff that's being released all the time. a lot of these devices, there's no reason for them not to have cameras. So how do we change when a camera may or may not be in any given room? So this was an experiment about using a proximity sensor, a camera from a mobile phone, a Raspberry Pi, and a little bit of something vaguely sculpture or clock-like to communicate to a room about a camera being there. It has a visual affordance for blocking the camera physically. If you want private mode, you just turn the dial and block the lens. Definitely we know the camera's off, right? If you want party mode, it can just be constantly taking photos. Then you don't have to worry about taking photos in the room or getting the photos after a party or something like that. It had proximity mode where it only took photos if you walked up to it. If you were standing within 2 meters, it would take a photo. If you weren't, it wouldn't. So interesting ways of playing with how people's behavior changes in a physical space when there's a camera available. How do you communicate to people in a space that a camera may or may not be there or may or may not be on? We don't have design language for this kind of stuff yet. The only design language we're getting is from Apple, Google, and Amazon. As designers and implementers of technology, it's up to us to really push on a design language that clearly tells people in a given physical room what type of privacy exposure there is. There may be a camera, but maybe it's not connected to the internet. Is that okay? Maybe there's a microphone that's connected to the internet, but not a camera. How do you know? How do you make decisions? How do we as technologists build technology that lets users make informed decisions about these types of things? We're in these rooms. Right now, we know when there's a computer there, but not for long. So the patterns of flow, types of architectures and topologies that we're working with are also radically changing. When we walk into one of these spaces, maybe we tap an NFC thing going through the MTR, an NFC chip, and that triggers a transaction flow that checks some database in MTR. Maybe a camera or a microphone detects us, starts causing an interaction flow. Maybe we get a notification on our phone. Maybe we don't. Something happens. We can flow directly into an app, but like I showed you earlier, the end game of having an app for everything doesn't look good. And especially as software is becoming more and more invisible, it's not going to be as common either. Well, we can narrow the set of apps. We have all these messaging apps that we all work with every day. We talk to our family and friends on, that we buy things with. Being able to use things like deep linking or QR codes to interact with these messaging systems, pretty powerful, but causes another secondary set of effects that maybe we don't have visibility into. We can load directly into a browser. We may or may not have more control at that point, depending on which browser you use. There also might be secondary effects of loading URL from a QR code that you don't know. There's no QR code scanner that I've found yet that opens that URL directly into incognito or private browsing mode. As soon as you scan that code, that URL's in your system. There's no undo at that point. I'd be really interested to see if these types of privacy forward patterns start coming out of physical computing. I would love, we have Firefox Focus, which is a private browsing browser. It's like Firefox, but all it does is one thing, private browsing, nothing else. I would love to be able to have a QR code scanner just launch me into that, right? For some URLs where I know what I'm doing and I know where I'm going, launch me into my regular browser. But for URLs where I can't tell, just put me right into Firefox Focus. Because I don't know where that URL is going. I don't know who runs the server. I don't know where my data is going to, especially if that QR code says something about my physical presence. QR code says that you're standing there in that spot. You don't need crazy NSA surveillance anymore. You don't need GPS. You scan the thing at the place. There's only one. Pretty easy to tell. So when you add secondary effects, we end up with these types of scenarios. You walk into a room, you get a notification, maybe you don't. All these secondary systems start kicking in. As programmers, as developers, we're now looking at, people complaining about the web stack getting more complex. Well, this is the new stack. This is the IoT topology. This is where you have one or more mobile apps, one or more devices, one or more different software platforms. I mean, especially with wearables, room scale computing, smartphones, however else we're interacting. This is a pretty basic and simple topology these days. This isn't even weird anymore. This is what it looks like, whether we like it or not. This is the type of software architecture that we're all working with. We did a survey of IoT developers. One of the number one complaints that IoT developers had, it's too complex. you don't know the secondary effects of decisions you make when you're choosing a platform, when you're choosing a tool, when you're and forget about debugging. There's no debugging tool that does all this. Forget it. You have a bug, you're going to spend weeks trying to disentangle this pile. So we need to come up now, as this technology is rapidly becoming part of our daily lives, better developer tools, better maybe trace tools for identifying patterns of communication across platforms. A lot of this stuff doesn't exist yet. As every room becomes filled with hundreds of sensors, hopefully we'll fill in the gaps. But who will fill in the gaps? As open source programmers, we have the opportunity and the power to be able to build these types of tools. When people get into these situations, though, what do they want to do? Oftentimes, people want to buy things. This was an interesting company that are based in Singapore, and they work on, the canonical example of IoT is the smart fridge. They actually make smart fridges. This is a smart vending fridge. Every piece of food in the fridge has a QR code, RFID, that's detected when it's moved out. You tap your phone to be able to pay or whatever. The entire thing is automated. It was designed for people who run restaurants that have a busy lunch hour and almost all their customers are taking the food for takeaway. So they just fill the fridge with food outside. People that want to wait in line can, but the people that just want to grab the food and go, they can do that by walking up to the front of the building and doing this. So it's kind of an interesting idea, especially considering how much grief that the smart fridge gets in IoT circles. Because really, who wants a smart fridge at home? No one. No one needs or wants a smart fridge at home. But a smart fridge at a restaurant? That makes a lot of sense. They're interested in, they don't want an app. They don't want you to have to install an app to buy their products. They want you to be able to walk up and just buy something without having to install anything. They want to remove the barriers between you and your lunch, which I thought was a noble goal. But they were asking about the Payment Request API. Payment Request API is a new web API that browser vendors are making now. Edge, Chrome, Firefox, I'm not sure about the others. But it's a way that you can actually do in-app payments in your browser app. So in-web payments, the idea that you can trigger the payment flow on Android or iOS from a web page itself, allowing you to buy something without having to install anything. This goes back to the use case changes. Mobile web use cases are different than desktop web use cases. Desktop, we have no problem. All of us enter credit card numbers into web pages. We enter our payment information into web pages all the time. But on the mobile web, it's a huge barrier. So this type of flow allows us to do that. I'm also interested in casual augmented reality, the idea that we don't need really high definition or high resolution augmented reality experiences. That when you see a lot of these augmented reality demos of dinosaurs walking on your coffee table, that's not something I'm going to be sitting around doing all the time. But informational augmented reality is pretty easy to do and kind of interesting, and I think we're going to see an explosion of use cases around that. So right now on a web page, you can access the camera through Get User Media. If you add something to it, you have now, augmented that experience. You are, wow, there's 3 of me on there. Hey. You can do things like add controls. Let's say I want a music player, and I want to hit pause. I walk into the bar. I don't like the music that's playing. Not only can I see the music that's playing, I can maybe see who started playing it. I'm like, I don't want to talk about it. Or, well, that taste of music is... But the different ways of interacting with groups of people with no installation necessary in a physical space. You can add a little bit of smarts to it, and you can have things like, hi, my name's Dietrich. But look at this. I don't know about you, but I had a huge empty space on my conference badge today. Everybody has an empty space on the back of these conference badges. What if we had an AR marker? So we're all walking around, and maybe we have our company's information or our name. Maybe we have the fact that we want to be in private mode right now. I'm busy, I don't have time to talk, sorry. Or maybe we have a big signal that says, come talk to me, I would love to hang out with you, please say hi. You have ways of sending social signals in an ambient way without commitment or any special platform required. You can do these types of things, and this is just Get User Media, a web page, and a little bit of JavaScript. You can add different ways to interact, like noise. I can make the duck move. I can't make it quack yet, but I probably could if I had more time to work on the demo. But the idea that you can make the digital parts of what you're doing interact with. Now I've got multiple senses right now. I've got the camera, I'm looking at something, I'm speaking, it's detecting my voice, and then augmenting the visual aspect of it based on the noise that I'm making. So these types of patterns where we have multiple senses, multiple physical interactions, and multiple layers of digital interaction are going to be pretty interesting, especially as new platforms are getting support for this type of functionality. AR.js is a really cool marker-based AR solution for doing this type of easy, casual, augmented reality on the web. Like we could print out those stickers for AR markers, put them on the back of our conference thing, and just hang out and watch people go by. It supports lots of markers at a time. It makes this type of use case pretty basic. This week, Apple announced ARKit, so the idea that you can build AR applications easily in iOS. I think we're going to start to see a lot more platform-level support for AR coming with it, and probably Google will announce something to compete with it. Get user media is the JavaScript API to use access to the camera. Very few lines of JavaScript. Works on Android, and as of this week, it also works on iOS Safari in iOS 11. So now we can do this type of access of media, camera, microphone, in most of the web browsers, in most smartphones. A-Frame. A-Frame is a toolkit for building 3D and VR experiences on the web. It's an open source project. There's a all afternoon workshop about A-Frame. It's a fantastic tool. It works based on elements. It's declarative, which means that it works with React, works with Ember, works with Vue. Very easy to integrate A-Frame into your existing JavaScript and web development toolkit and flow. It makes it very easy for newcomers to build 3D for the web and VR for the web. It's what I use to be able to do some of this stuff, to overlay 3D objects on top of the camera view. Has basic primitives for 3D objects. You can import object models. There's the basic, you just add a sphere, you get a sphere. It's got JavaScript extensibility, so you can add components for custom things as well. Almost all the stuff I talked about so far is MDN, which is made by Mozilla and an open reference for web technologies. If you haven't been there before, it's fantastic. I use it every day. But that's about making. As this paradigm shifts, as we change the way that we're making these things, how do we integrate privacy and security? How do we know when we walk into a room, whether, even if it's a web-based solution, what the privacy exposures are? It's something that we don't really know yet. With these devices, they really are, well, two black boxes and a white box, I guess, white and gray. But we don't have visibility into a lot of what's happening with the data and these things. We don't have access not just to decide our own future, but not even to decide our users' future or have any visibility into it. What happens when it starts to look like this? When we can't see the software at all. We can't see the hardware at all. Here, at least we know these companies can be sued, or these companies at least have to abide by some laws. They haven't all moved to space-based business models yet. Once these three companies move to space-based blockchain business models, then we have no choice at all. But we also have the freedom to make our own, I guess, right? But when you can't see the software or the hardware, the amount of choice is radically decreased. And the architecture that happens becomes more complex, harder for us to follow, harder to debug, harder to know what our level of exposure is, let alone our users. Or as programmers, people building businesses on top of these types of ambient topologies where we can't see what's going on, we don't know what's going on, becomes even more challenging. And eventually we end up in this future. This is a fantastic video called Hyper Reality, where this artist took the idea of augmented reality and IoT to the extreme limit, where everything that we see is augmented all the time. Now, like it or hate it, this is the trend that we're seeing. This is the future that we're heading rapidly towards. As open source programmers, developers, designers, we have an inordinate amount of power because we develop a lot of the tools that even those big companies are using to develop their solutions. We have the opportunity to design the privacy language, the security best practices that we would like to see in the world, more than almost anyone. So we're entering a physical computing world. It's happening way faster than anyone thought. And we as technologists, have a lot of power to affect how this future looks, how it feels, and how it behaves. Thanks for having me today, and come find me afterwards if you want to talk more about this stuff. And don't forget, there's an A-frame workshop this afternoon that looks fantastic. Thanks.